Okay, let's talk about another piece of the transformation equation. It is function distortions. We do not really call them distortions. What we do call them is we call them stretches and compressions. And our A value in the transformation equation, that's going to give us a vertical stretch or a compression. Your B value is going to give you a horizontal stretch or compression. And I just wanted to give you a little warning that our B is insane. And I will talk more about that in just a few moments. Let's go ahead and move on and talk about vertical stretches. So your vertical stretch has to deal with your A value. And remember, your A value is not in parentheses. And if it's not in parentheses, it's ordinary. What you see is what you get. So for the A value, if it is greater than 1, it is going to be a vertical stretch, which means the graphed function is being pulled away from the x-axis. It's going to get real skinny and a little closer to the y-axis because it's getting pulled thin vertically. On the flip side of that, we can also have an A value that is less than 1 but positive. In other words, a fraction or a decimal. If you have an A value that is a fraction or a decimal, it gets pushed towards the x-axis. It's getting squeezed. It's getting compressed down towards the origin. And remember, that means that it is going to flatten out. And of course, your A value can be negative. Remember, that was covered in a previous video. If the A value is negative, that does not have any effect on a compression or a stretch. It just means that it is reflected across the y-axis. Let's go ahead and talk about horizontal compressions and horizontal shrinks. So remember, that is when you have a value being multiplied by the input. The input's being multiplied by some value right there. So what this is going to mean is that it's really kind of flipped. This time, if your B value is greater than 1, that's actually considered a compression. And what's going to happen with that is it's going to get pushed towards the y-axis. So it is being squeezed horizontally. It's getting closer and closer to the y-axis on both sides. So on the flip side of that, of course, we will have fractions for B values. And if we have a fraction for B values, it is getting stretched away from the y-axis. So it's being spread out horizontally. And just like you have a negative A value, you can also have a negative B value. Just remember, your negative B value is a reflection across the y-axis. Okay, we're going to focus a little more about B. B is on the inside. Remember, I told you at the beginning, B is insane. Just means that it's counterintuitive and that it's opposite. Let's take a look at this first example. So for this first example, we have y equals f and then a 3 of x. So let's go ahead and remember, let me grab something to remember, that was the new value. And that's the value that we're looking for. So we have to figure out what it was based on the old value. So how would you solve for the new? Remember, this is 3 times 1 over n. I'm sorry, this is 3 times x sub n. How can I make that 3 go away? Because we want to isolate the x sub n. You could divide by 3, or you could multiply by the reciprocal. That is the same exact math. I am going to multiply both sides by the reciprocal, which is going to be 1/3. Of course, these cancel out. So if you need to find x sub n, then you know that it is going to be 1/3 of whatever the original output is. So again, B is inside the parentheses. It's a little crazy. By the way, that 3, that is greater than 1 initially. So that is going to be a horizontal compression. So remember your rules for that. When the B value's above 1, it's horizontally compressed. However, we do have an additional piece of information, which is very important. That looks like a brand new word, BAFO, and you'll hear your teacher say BAFO, but what that really stands for is by a factor of. So this is by a factor of 1/3. And this is only applicable to B values. This is only applicable to horizontal compressions or horizontal stretches. So memorize this terminology. You will definitely see this. BAFO, by a factor of. Your horizontal stretches and compressions are always by the reciprocal. Let's take a look at a couple of, or one more example. The next example I wanted to show you is y equals f of 1/5 of x. So you have a b value. Your b value is a little crazy. First of all, your b value is a fraction. If your b value is a fraction, we know that this is a horizontal stretch. And what is the reciprocal of 1/5? The reciprocal of that is 5. So you have by a factor of 5. What does this mean? All the original x coordinates have been multiplied by 5 to make your brand new x coordinates. Here I am back on your dilations template, and if you notice, I crossed out the word dilations and wrote the word distortion because it truly does change the shape of the function. So let's go ahead and take a look at what a horizontal stretch or compression is going to look like for this graph of f. So let's take the graph of f and let's do a horizontal compression and go ahead and use our previous example 3 of x. Now, remember, this is a horizontal compression by a factor of 1/3. So all of your brand new x coordinates are going to be a third of your original x coordinates. There is no change on the range, and let's go ahead and graph what this looks like. Let me move up to the picture, and if you notice, we are doing in thirds. So you're going to have to just kind of estimate where your thirds are on your coordinate grid. Here we have a -2. So if I have this -2, I'll show my work at the bottom. So the original x was a -2. But remember our new terminology, BAFO. So what's really happening is that -2 is being multiplied by a factor of 1/3. So our brand new x coordinate is -2/3. So let's go back up to our original graph. Here I am at -2. I'm going to kind of estimate where 2/3 is. It's going to be greater than 1/2, so approximately right here. And that's going to be the first stop for the horizontal compression. The next ordered pair that I see is down here at -1. -1 multiplied by 1/3 is going to leave 1/3. So a -1/3 is less than 1/2, so approximately right here. And I'm going to connect the dots as I go. So let's take a look at our next ordered pair. Our next ordered pair is 0, 2. That is stuck on the y-axis. If it's stuck on the y-axis, it cannot be pushed away or pulled towards the y-axis. So that ordered pair, 0, 2, that stays exactly where it is. My graph's getting pretty skinny here, so it is definitely a compression. This is a +1. +1 times a factor of 1/3 is going to be +1/3. This is going to be 2/3. So this is not stuck on the y-axis. This is the x-coordinate of 3. 3 times 1/3 is a positive 1. So that is going to be y equals f of 3x. Let's go ahead and take a look at a vertical compression. So a vertical compression, remember your number is going to be on the outside. And your vertical compressions, all compressions are fractions. So let's have a vertical compression of a half. So over here we have terminology by a factor of a third. If I ask you what the vertical batho is right here, you're not going to change anything. It's just exactly what it is. So the batho, that sounds so weird, by a factor of just a half. Remember, you never mess with the a values. They're not insane. They're not inside parentheses. So your brand new y coordinate is just going to be half of whatever the original y coordinate was. Let's go ahead and graph based on the original function that I have in green, orange highlighter here. These y coordinates are going to get cut in half. So this is a y coordinate of a positive 1. Half of positive 1 is a half. So we're going to start out our graph right here. The next one right here, this is a y coordinate of a negative 1. Half of negative 1 is negative 1/2. Next ordered pair is 0, 2. Half of 2 is 1. Next ordered pair, you're going to have a y value of 1, so it's going to turn into a half. Y value of 3, this is going to turn into 3 halves, or just 1.5. And then your last value right here, your range is 0, or I'm sorry, your y coordinate is 0. You cannot have 0, so it's going to stay right where it is.